I'm the hormone specialist, pharmacist Layne Kilpatrick, and this is you, Chief Medical Officer. Welcome to the podcast. My guest and your advisor today is Dr. Shanna Swan, a distinguished PhD environmental and reproductive epidemiologist. Mouthful. Dr. Swan's a professor of environmental medicine and public health at the Icahn School of Medicine at Mount Sinai in New York City and adjunct faculty at UCSF in California, where she currently lives. She's world-renowned for her groundbreaking research on the impact of environmental exposures on human reproductive health, which is of great interest to me because hormones are richly involved in that process, as you can imagine. Her work's focused on the effects of chemicals like phthalates and BPA on men's and women's reproductive health, as well as on the neurodevelopment of children. She's probably best known for a co-authored paper on the male infertility crisis, which became one of the most referenced scientific papers of 2017. She's also the author of the 2021 book, Countdown: How Our Modern World is Threatening Sperm Counts, Altering Male and Female Reproductive Development, and Imperiling the Future of the Human Race. I've read this book twice, at least. Not only is it my go-to book for its data and studies and facts, it's a visionary treatise on the subject. It's not just a data dump of bad news. It'll get you thinking about the serious implications of the data, yes, but it also provides solutions that you can implement right now, today. Honestly, I don't know of too many scientists with such pressing information for our day. Thankfully, Dr. Swan's very generous with her knowledge, and she's issuing a call to action here that I support, and I'm pleased to amplify here on this podcast. So let's meet her right now. Thanks so much for agreeing to talk with me. You've been on some big programs, Rogan and even 60 Minutes. That must have been an experience. But thanks for recognizing that.
And just last week, impact theory. Are you familiar with impact theory?
Yeah.
Yeah. I just did that last week.
Oh, great. Well,
and then I'm going to Concrete podcast in a couple weeks. So those are all
good.
Big. Yeah.
I'm really happy to hear that message getting out. And we're a fledgling little operation. So thank you so much for acknowledging us and helping us get started. I've got a follower group that's just a passionate group of people that are very likely to take action on this stuff. And so we're excited.
So,
I've been
Layne,
looking forward to this.
What is your background?
I'm a pharmacist, clinical pharmacist. My practice here has focused on hormone therapy for, nearly 30 years. And it's a little different than what you'd expect from a pharmacist because I spend a lot of time with patients. A lot of people start here with me. They'll have issues. They don't know where to go. Spend a lot of time with patients helping them kind of get connected and plugged in. As you know, this area of hormone therapy is, it's sort of like, for a while there, it was nobody's baby. Nobody was really doing it. Everybody ran from it.
So when you say hormone therapy, are you primarily talking about testosterone, TRT?
Well, no, all bioidentical, all male and female patients and of all ages, actually. I don't do pediatrics. I don't see them. But so in that effort, I've really kind of dug deep into the clinical side of it. And so I just kind of help screen and I help direct them to practitioners who are good at it, know what they're doing. And so this idea of hormone disruptors, it just falls right into line with what we do here. And it's just really been embraced by my audience. So a lot of interest there. So that's what I hope we could talk about today and just kind of jump into it. So you're an environmental reproductive epidemiologist.
Right.
So let's define epidemiologist. That's if I understand correctly, frequency and distribution and perhaps control of diseases.
And causes. And their causes.
And causes. Okay. And their causes. Thank you. So you're a prolific publisher, over 140 papers at my last count. You've done
200, over 200.
Okay. Yeah. Well, Wow. Okay. So it's a lot more than that. That's a lot. You're a respected voice in the field. And you published this review and analysis called Temporal Trends in Sperm Count. Temporal meaning over time, over a lot of time.
Yes.
Is that correct?
Yes.
All right. And so I think Andy Warhol said, in the future, everyone will be world famous for 15 minutes. Would you say that, is it fair to say that this blew up in the media and was your 15 minutes of hyper fame? I mean, you're well known. There's no question about that, but
it was certainly bigger, I think, than anything else I published. Yeah.
Well, it has to be exciting.
We're on Time magazine and
yeah. And it has to be exciting that it reached that level of the level of patients and everyday people rather than just, the academic world, where you guys tend to hang out.
Right.
But so my hope today is that we can lay this out in such a way that listeners can plug this into their personal situations and really understand how it works. So let's start with some basic anatomy and physiology if we can here. Right at the beginning, actually, in the womb. So embryology, I guess. In a genetic male, so an XY male, there's a point of differentiation that's critical at about week 7 or 8. Can you just talk about what that is and how we get going down the road of it becoming a male fetus?
Well, being a genetic male, of course, is a property of every cell in your body. But I think what you're talking about is the development of the genital and reproductive tract, which is where I kind of focus.
Right.
And we actually don't know the exact time. In rats, we know really clearly, because in a rat, you can dose the pregnant mom at specific time periods and see what the effects are in those time periods. But in humans, we can't do that. So in humans, all we can do is look at markers of exposure, which happen to be urinary metabolites of the exposure, because that's what we can look at. We can't get into the womb. We can't get the amniotic fluid, And so based on that indirect measure, you have to say, okay, what urine sample, whether it's the first trimester, week 8, week 10, week 12, what urine sample gives us the best, strongest association with the outcomes we're looking at, which we haven't discussed yet. But anyway, I'm just talking about the timing issue. So, and just to say that we've come closer in our studies than anyone, but all we can say is that we see an association in first trimester exposure and not in later associated with later exposure. Okay, so we know it's first trimester. In rats, there's actually just a few days. It's, 18 to 21 gestation. That's really precise. Wow. But that's because of the serial dosing that's possible in a rat. So as far as when exactly this happens, it's probably early first trimester. Finer than that, I don't think we can say. So what happens? Well, in the human and in the rat and in all mammals, almost, the testes start to develop in the male and produce testosterone. And that production of testosterone drives the differentiation of the previously undifferentiated genital, what they call the ridge, or genital tract is just a line when you look at it, and you start to see, for example, what will become the ovaries then become the testes and move off away from the genital ridge, and so on. So this progression of development of the differentiation of the genital tract, governed by testosterone, and leading to a difference in the genital tracts of males and females that we recognize.
Okay.
So if this is interrupted, either because the testosterone isn't there to start this and to drive this process, or if it's there at a lower level than needed, or it's there late. Late is really important because timing is really critical, as you know, to embryological development. So anything that's going to drive down testosterone or alter the timing or the amount of testosterone is going to interfere with this process.
Okay. And that process being the formation of a penis and the differentiation. So from this point forward, the fork in the road, we're going to a physical, a phenotypic male. And if that doesn't happen, by default, we're all female, yeah? In terms of what?
No, we're not female.
Well,
but the genital tract fails to differentiate.
Right.
And so in our studies, when we've looked at that and we've seen this process interfered with, we say that the males are incompletely masculinized. There always is some change in the direction of the masculine. I don't know of any paper that's ever said nothing happens at all.
Okay.
But you see an incomplete. This process is not complete.
Fair enough. Okay.
Right.
So then now let's move. So that's a critical time when testosterone has got to be there, and if it's not, there are issues. Let's jump ahead now to say 10 or so when sperm are beginning to be produced, comes into full puberty and makes 200, 300 million sperm a day. Is that accurate?
Yeah, a lot.
That's a lot. Not all of those proceed to full maturity, right?
Right.
But that process of maturation of sperm is a 60 to 75 day process. Yeah.
Yes, that's right. Yeah, that's
all right.
The ballpark. Yeah. Mm-hmm.
All right. So what we do today then will affect those sperm that are released 2 months or so from now, which is something that I don't know that everybody really grasps. But so let's keep that in mind because we'll come back to that at some point in the future. So moving on. So an average man will ejaculate about 5 mLs or a teaspoon of semen, right? Which contains by those numbers, 75 million to a billion sperm or used to.
Right.
Yes, or used to in 1973, right? Was that your finding?
Right.
So how about now? What is it? What is it containing now?
Yeah. I mean, our last look we published in November. Did you see that paper, November 22?
Mm-hmm.
And there we saw that the decline was actually stronger than we had seen previously. But it's less than 50 million per milliliter of sperm compared to about over 100 back in 1973. So it's a more than cutting in half the number of sperm. In a sample.
And that's.
But Layne, let me just say, the link from altering the development of the male genital tract to the production of sperm is not straightforward, right? Because it's not that the sperm are missing in utero. There's only germ cells there. And that link is still not as completely understood as it should be. In other words, if you disrupt through chemical or other means the production of the male typical genital tract, what does that do to sperm, right?
Mm-hmm.
Right?
Long term.
Yeah. Mm-hmm. When the baby is a guy. Right?
Right. And he's ready
but the baby is not making sperm. So you can't say that process in utero, right, it's not affecting, there's no sperm.
Gotcha.
There's germ cells which will go on to produce sperm.
And the germ cell being, that's what's forming in the testicle that's going to going to be reproducible and splits.
Right.
Okay.
So I mean, we can come back to this, but actually, and we haven't talked about what a deficit of testosterone actually does to that genital tract. But when we talk about that, I will also talk about how those changes are associated later with decreased sperm count.
Okay.
Right?
Yeah. Well, let's just do that. What are those changes that can be seen when there is an interruption or a lack of sperm at that critical juncture?
So there is something called testicular dysgenesis, which was a term that was coined by Niels Skekebæk in Denmark. TDS, testicular dysgenesis syndrome, and it's very similar to what was later called the phthalate syndrome. Now, phthalate, of course, is an exposure. That's a chemical that we're exposed to in our daily lives as adults or as pregnant women. And so it was really interesting to see that, maybe one cause of TDS is phthalates. Because if you look at what is the phthalate syndrome, what is TDS? So the phthalate syndrome is what's produced initially seen in rodents when the mother is given phthalates. So when the mother is given these chemicals that make plastic soft and flexible and so on, chemicals we're all exposed to.
And preservatives and several different sources, right?
Right. And we can talk about those. But when in the rat, in the laboratory, the mother food is they put the phthalates in the food. And then they wait till the baby's born and pup is born, and then the pups are measured in various ways. And what they discovered back around 2000 was that when the mother was given several phthalates which were known to lower testosterone, anti-androgenic phthalates, which most are, by the way, then the male is slightly different, slightly under-masculinized. And that means he has a somewhat smaller penis, scrotum, undescended testicles, right? I didn't mean undescended scrotum, undescended testicles. Right. And sort of most interesting to me was that the entire distance that the genitals take up, which is called the anogenital distance from the anus to the genitals, that was shorter than expected in a male.
Which turned out to be a uniquely important metric.
Uniquely important, yes.
Yeah.
And in this differentiation we talked about that starts early in pregnancy, one of the things that happens is that this anogenital distance, which by the way is called the taint or the grundle and street talk, right? I mean, kids know about this. They call it the taint. That distance becomes longer, and it makes sense because there's a lot more to go in there.
Okay.
Right. And but if the mother is exposed to something that's anti-androgenic like phthalates, or if there's a genetic condition like CAH, which changes the amount of testosterone, and you understand the potency of testosterone in this whole thing, and so anything that's altering testosterone doesn't have to be phthalates, will interfere with the development of the genitals. In particular, it will mean that a male anogenital distance, or AGD for short, is shorter than expected for that pup's size, right? And by the way, there's an impact on females as well, which we can talk about later. Okay.
Okay. So you've got some things that develop here, or rather don't develop, and you guys in your research, you're looking for things that are going to make a difference later down the road, but also right now. I mean, there's an increase, as I understand, in these manifestations of this blocking or inhibiting of testosterone. You mentioned that anogenital difference turns out to be an important indicator of fertility. There's the formation of the penis. There are conditions like hypospadias, where they're deformities essentially, aren't they? Yeah. Where it just doesn't form properly, and there can be some surgical corrections there. But these are undistended testicles. Those things are disturbing to young parents. Nobody wants, but the frequency is really increasing. You don't hear about it because nobody sends out an announcement and says, "Hey, we got some problems here." No, they want to share their joy and their excitement at having a new baby. But these things are on the rise, are they not?
Actually, we don't know that. I suspect they are, but nobody has done a study of how these things have changed over time. We couldn't go in the past because actually my team was the first to measure this in human populations. So there's no historical data on this. In an epi study, there are measurements. There are isolated measurements. For example, there was one paper that showed that it affects the androgenital distance is short in CAH. Particularly long in CAH girls because they have too much testosterone, congenital adrenal hyperplasia. So that's so that was measured. There are isolated papers that talk about it, and there's one Mexican paper that looked at it. But to actually link it to phthalates and show that there is a phthalate syndrome, which is what it was called in rats, that it actually exists in humans, that was our work. We were the first. So if you want to say, has this changed over time? It's difficult. I mean, it would be possible if you could measure men of all ages and measure their AGD. Then maybe you could see that older men have longer AGD than younger men. Okay.
So how about these kids who were born with hypospadias or cryptorchidism? Those aren't descending. Don't we have some data that show that is more frequent?
Those are on the rise.
Okay,
hypospadias and cryptorchidism are on the rise,
which are indications that we've messed with the testosterone delivery somehow.
That's right. Okay. As is, by the way, decreased fertility, increased erectile dysfunction, increased use of testosterone by young men. I'm sure you're familiar with this. And these are all indicating that this system is not going well, I would say.
Yeah. So let's talk about that. What are the lower limits of fertility then here in terms of sperm concentration?
So 0. 0 sperm, 0 babies. I think everybody understands that, right?
I think so.
Unless you're going to use donor sperm. Okay. Assisted reproduction, but leaving aside assisted reproduction. Okay, so there's actually one really beautiful, elegant paper out of Denmark, which looked at couples that were trying to conceive. And they had never tried before, and they had no barriers to fertility that anyone knew about. And so they stopped contracepting to become pregnant. That's very difficult to do this study. But they did it. And what they did was they got a semen sample, and then they saw how long it took the couple to get pregnant, right? So time to pregnancy or probability of conception per cycle. And what they found was kind of interesting. If you have a lot of sperm, suppose you have 50 million per milliliter, which is a lot, or 100, or 150, it actually doesn't matter. It all works. It's an excess, right?
After there's a point of diminishing returns.
Exactly.
Okay.
Well, it doesn't hurt, but it doesn't help.
Right. Maybe insurance, right?
Yeah, insurance, right? But when you drop below 50, the probability of conceiving in a given cycle, a given attempt, goes down rapidly. And so at 40, it's already, halved, cut in half your probability of conception. And then it drops off to 0, because obviously 0 sperm, you have 0 conception. So when people say, well, sperm count doesn't tell you about fertility, I would say yes and no. No, if it's very high, it doesn't matter. If it's 50 or 100 or 150, that doesn't tell you anything. If it's low, yes, it does tell you it's going to take a long time to get pregnant. And the definition of infertility is that it takes 12 months or more. And so what we're seeing is that the probability of infertility increases as sperm count goes down, and 47 million per milliliter is in the zone where men are already subfertile.
Okay. And hasn't the bar kind of moved there by the World Health Organization, where they've actually lowered it over time?
Well, the WHO standards are kind of strange. And actually, they used our data in the latest publication. But what they are is they're on fertile men. They only used fertile men.
Oh.
So what does that tell us about infertile men, right? I mean, and in what they did was they looked for the 5th percentile for fertile men, and below 15 million per milliliter, that's their cutoff, they say a man is infertile. But that's based on fertile men.
Oh, okay.
So, you really need that for everybody, but
right.
So
right.
And our study was our original study was in fertile men, so partners of pregnant women.
Okay.
Right. So that's why they used our data. Yeah.
So would you go into the factors that come together to determine semen quality? Let's just okay.
Yeah. So of course the number of sperm we've talked about now, right?
Concentration.
There's also the movement and the motility is how it's referred to. And obviously, if the sperm doesn't swim, it doesn't do the job.
Doesn't arrive.
And if it swims in circles, it doesn't do the job. So straight line motility is important, that it goes in a straight line. And there's other aberrations you can have, but and then there's the shape. So it's odd. When I first, it was odd to me to learn that there were problems like 2-headed sperm and 2-tailed sperm and sperm with unusual density. That's another defect of morphology. And so it's very hard to be morphologically correct sperm, and only about 12% are. 12%.
Okay, wow. So that
in a healthy sample. Yeah.
That explains why higher numbers are going to be important.
Right. So you can have sperm which are weirdly shaped and which swim around in circles or in zigzags, and so they're all suboptimal, let's say. And I think that's why.
Okay.
The other thing that can happen is you can have chromosomal damage. And that's not usually checked, but that's important as well.
Okay. Not generally checked.
Well, the routine, the first pass, if you will, is the 3 big ones: the concentration, motility, morphology.
Okay, all right.
And DNA damage is next.
So any one of those 3 obviously could cause some fertility, but if there are more than one, say 3, for instance, it's not just additive risk, is it? It's actually
knocks you out of all 3.
In fact,
and they're correlated. So if you have one that's bad, you're going to be more likely to have the others that are bad.
Okay.
So, yeah.
But rather than 3 times the risk, say, doesn't it go up to something like, I don't know, 6 times or something like that?
Yeah, right.
Okay. So it's not just a linear thing. All right. So men usually don't know these things about their fertility. They just, they probably should, but why do you suppose that is? I guess it's because we just don't go to the doctor very much. We feel like, I can still ejaculate, so I got to be fine. I'm sure I'm good. Well, that's not necessarily a safe assumption, is it?
It is not a safe assumption.
In light of what you found out.
And the other reason, aside from fertility, that the man might want to know this is it tells him something about his overall health. And so just like a woman gets a checkup every year at the OB/GYN, right? I feel that men should be checked too. But like you say, men don't want to do this. And frankly, if there's a problem, men don't want to talk about it. So, you might go to a doctor and get get a bad cholesterol, high cholesterol value, or, your blood pressure's bad. And you might say at a cocktail party, I had these bad numbers, my cholesterol's up, I got to watch it, I got to, but you wouldn't say, I went to the doctor and my sperm count is in the toilet. You know,
Not going to post that on your social media.
Right.
Yeah. Well, true. I mean, I think that men would do something if they knew how important it is and what a threat it is. They might do something more. But you're absolutely right. It's sort of not in our nature.
But Layne,
to look after
I
those
just
things.
want to also add here, because I don't think I made it clear, men with low sperm count and infertile men die younger.
Yeah, you did. You did make that clear, and I wasn't going to gloss over it. I found that fascinating in your book and your research, that these seem to be a marker of some sort, whether it's a surrogate marker or what's the association. Maybe we don't know, but it's there and it's strong.
Right.
That where this is an indicator of something else going on.
Right.
And so that in and of itself ought to be a good metric to keep track of for men's health.
Right.
Yeah.
Right.
Okay. Well, that's fascinating and that's interesting. So anyway, there's a disconnect here for sure. And like, for instance, if a woman has a miscarriage, nobody really thinks it could have been the man's fault, right? We just automatically, I don't know why,
right.
But it's true. Men need to take accountability for what their contribution is, and they have their half or more.
Right.
That nobody seems to really, I guess, know about, because do they really break it down to that point after something like that happens and say, okay, this is what went wrong and this is whose fault it was?
Sometimes, there are male causes and female causes and unknown causes.
Right.
About 1/3 each.
And this might be where those chromosomal damage or abnormalities you talked about would come into play, right?
But the chromosomal damage could be on both sides as well. So you have to be a little careful about that.
Right. Well, this needs to come to light for sure. It needs to see some light of day be shined on it if people are going to get to the bottom of what their fertility issues are. And there are increasing numbers of fertility problems, no question. I see it just in my office. I can't believe the number of men that I see in their 20s with a testosterone level in the 200s or even lower. One guy. That's so let's talk about for a second the link between testosterone and fertility. Are you thinking that that the testosterone might be driving the fertility issues?
Absolutely.
Because you just looked at sperm count.
Right. And actually, we are now doing a similar time trend analysis of testosterone. So that will be interesting. But from talking to people like you who see in their practice low testosterone in young men that they've never seen before, I think there's little doubt that low testosterone is a growing problem, increasing in young men particularly. And a lot of men, by the way, I'm sure you counsel them properly, but a lot of men don't know that if they take testosterone replacement, they're going to wipe out their sperm. They're going to make them infertile. So there's no question that there's a relationship.
And let's just touch on that briefly for the benefit of the listeners. If you give testosterone, I mean, that's certainly not the first thing that we do, just anytime someone's testosterone is low. It's just the entry point. It's a point of data, and it comes into balance along with the patient's age, what they're trying to accomplish here. But giving testosterone will just throw that into the loop, and it just actually shuts things down further. You're right. So, but it's been so fascinating to me because these are strapping young, athletic guys that, I mean, you look at them and that's the last thing you think of is that there would be issues there. But I think it just goes to show you that you don't wear it on your face. You don't wear it on your.
So I'm now I'm going to ask you a question.
Yeah.
So what do you do for these young men?
Well, because I'm not a practitioner and I'm really not a proper diagnostician, I feel like my job is to help them understand how their system works, what is available to them out there in our current state of knowledge around this, and then get them in to see some people. But I do go over what some of those options are, and some of them would be, okay, let's try and determine what it is that's causing this, this is what your practitioner might do. She may order these labs. Let's look at if it's possible to stimulate your own production, get things going yourself. We could look at causes, and that's helpful in so far as it leads to some behavioral changes or some limit some exposures to things that are causing some of this. This is what they come in for. They don't. How in the world did I get here? Totally did not expect this, and they didn't find out until they went to go ahead and try and have some children.
Right.
That's
or possibly that they had not the sexual function that they expect.
Mm-hmm. Right. Of course.
Right.
Yeah. So all kinds of reasons that lead them in to me, but they're looking for understanding around this, and it's tough for a man to come in and ask about that sort of thing.
Oh yeah, yeah.
Just not used to it.
Right. So one of the things that is not, maybe they don't want to hear, but I have to say, is that let's go back to the development in the womb, and that's when that man was in utero before he was born. And if his mother was exposed to things that lowered her testosterone and therefore his testosterone, the cause might be all the way back there.
Mm-hmm.
And this distance, this anogenital distance, is a readout of how much androgen he was experiencing in early pregnancy. It's just fascinating. It's a marker. So we can't actually look in there. We can't get amniotic fluid. We can't go in there. There's no scan that would tell you how much androgen or testosterone was in the womb. But the AGD grows in response to the testosterone. So if it is short, it suggests a low level. And if it's long, as we see, it's more on the long side, it's more an indication for females, that female got more than expected testosterone. And an example of that is if the mother has PCOS, polycystic ovarian syndrome, she is high testosterone. That's a defining characteristic of PCOS.
Yep.
And then her girl, unborn girl, is exposed to more testosterone. And guess what? That girl's AGD is longer than expected.
Longer. Wow.
So it's just a readout of how much was in there, as well as a predictor of future function.
That's an interesting little point in time measurement, isn't it? That you could look back and say, this tells a story of what happened then. And then, but maybe more importantly, so what does it mean? What does this mean for you? And of course, everybody wants to go out now and measure theirs. So
right.
So what are they looking for? What is there an average? Is there how do they read that, or should they?
Yeah, that's such a difficult question. Before I go there, let me just say it does matter. And we saw that in a study of ours, and then there was a study at Stanford. And what we did was we brought college students, mostly recruited through teams, athletic teams.
Who want money and will do anything, right?
Yeah, right, exactly. and they gave us a semen sample, and they let us measure their AGD, and they completed a questionnaire, and they gave us urine and blood. They did everything. And what we saw was that when the AGD was shorter, the shorter the AGD, the lower the sperm count.
Interesting.
Linearly. So it really does relate to sperm count. But and Mike Eisenberg in Stanford did that study, and he also looked at men who had children and not had children. And he saw that the men who never had children had a shorter AGD. So that there was a link to fertility. So as to what is a good number, I'm not going to say, because it's not an absolute. It has to do with a lot of factors. Your body size, for one. If you say, what is a good shoe size? And you're 6'7", compared to me, I'm feet. You have to look at a number of factors. There may also be racial ethnic differences, which we don't know yet. There may be other differences having to do with your age, it's possible. We don't know that AGD never changes. It may well change. Your height does change as you get older. You get shorter. So, so it's, I won't give you a number.
Okay, fair enough.
But, and I know that men want to know this. The other thing is that it's not that easy. It's not hard to measure in a doctor's office. A trained person can measure very easily. You use a standard calipers, and there are locations for the two ends of the prongs on the calipers. So anus and then the genitals, and the genital point is a little tricky, and we could talk about it if you want. But to measure that, you have to know what to measure. Okay. And then you have to know how to measure. Just like measuring head circumference on a baby at birth sounds really easy, but it's not actually so easy to get it standardized. Where on the forehead do you put it? How, where around do you, and so forth. So measurements really have to be done in a standardized way. And that's the reason I prefer not to say.
Okay. So is there a don't go below distance?
No.
No. Right, so it's quite broad then in its range.
And the differences are very small, by the way.
Okay. So these are relative things. And so,
the difference between a male and a female on average is 50 to 100%. That's a big difference.
That is, yeah.
Right. But within males, there's not a big difference. You might be 5% each point, 5% difference. 10% would be a very big difference.
Would a practitioner, I don't know what practitioner that would be, but could it be an indicator to them that this is, maybe we better check fertility?
No, I don't think you'd see it.
No, okay, all right.
You wouldn't see it and say, "Oh my God, this kid has a really short AGD," unless there was an extreme that I don't know about.
Okay, well, but what it does tell us is that there are markers and that there are indicators that this damage has taken place, and that it translates to. I'm glad you made that link. It translates to fertility, so that's an issue. All the more reason for men to early on to get their semen analyzed and look at what those parameters are, because if they need to do something, isn't it best to do it while they're young and their sperm is as healthy?
It does decrease over time.
Yeah,
not as fast as women's fertility going down, but men's does as well.
Okay, yeah. So, and there are options out there where they can freeze some sperm if that's the case. They're not ready at that point in their life to go ahead and start their family. Okay.
And by the way, just let me say, Layne, there are companies, and I won't discuss brands because I don't do that, but there are companies that make this pretty easy. So in the past, if a man wanted to get his sperm count checked, he had to make an appointment. He had to go to the doctor. He had to go into a private room and collect the sample, and it's a little embarrassing, and so on and so forth. But these companies are allowing you to do this at home, and you can mail them in. And it's really interesting because the count doesn't change over time, and the shape doesn't change over time, but the motility does. So the motility goes down with time. And what these companies have been able to do is to standardize, if they know when the sample was collected and they know when they've received it into their laboratory, they can adjust for that time and get an estimated motility had that been measured at the time of collection. And they get quite good results that way. So I just recommend that if your listeners want to be tested and you want to do it in the easiest way, you can go online and you can look for companies that do this.
Those options are there. Okay, good. Let's look at a startling fact here on fertility. You say in your book, worldwide fertility dropped by 50% between 1960 and 2015, and in some countries it was worse than that.
Yes.
Yeah?
Yeah.
How did you control for just changes in trends and socioeconomic issues? Because I found that interesting.
That doesn't say why. I'm not saying why. Okay, so let's just start with the fact. The fact is, and anybody who is curious can go online and Google World Bank fertility data. 4 words, you'll get great interactive website in which you can put in the country and the year and see the decline in each country yourself. Okay, so that's, no brainer. You can do
Not
that.
disputed.
And what you're looking at is what's called the total fertility rate. And that's the expected number of children a couple will have in their lifetime. Okay? And so if that's 2.1, that's called replacement, because the man and women each replace themselves and with a little extra for loss, right? So 2.1 is replacement. And back in 1960, that number was for the world 6 children per couple. Okay? And in 2015, it was 2.4, I think. So more than half, cut in half. And by the way, that rate of decline, slightly over 1% per year, is the same rate as sperm declines, and cryptorganism goes up, and so on and so forth. These trends seem to be following a similar pattern, which is, for me, not surprising, given that they probably have common causes.
Certainly
and
suggestive.
The fact that there's a common cause is suggested by the similarity of these declines. So let me just say, back to the fertility data. I haven't checked every country in the world, of course, but I know that pretty much every country I looked at has declined markedly in 50 years, with the exception of Israel. And what's interesting about Israel is that their use of assisted reproduction has been increasing dramatically, and it's one of the only, if not the only country that pays for 2 live births through assisted reproduction.
Oh, wow.
So the proportion of live births that's through assisted reproduction has increased in Israel. And that is probably why their fertility rate has not declined.
Taking a proactive
some countries, the lowest I know is South Korea. And so remember, we're looking for 2.1, that's replacement, if we want to replace everybody. And in South Korea, it is 0.89.
Oh, my goodness.
So the couple is not even replacing one of the partners.
One of the partners. Gosh.
Right.
Well, and in this country, I think you said in your book that the total birth rate for women in the U.S. was 16% below what's considered necessary for a population to replace itself over time. That was in 2017. Yeah.
Yeah.
Oh my gosh. So we must be worse now, or are we?
We are. The birth rate is gone down.
Well, oh my gosh, that should be concerning. I mean, some people will say, well, population's too high anyway. I don't want to open that can of worms here in this discussion, but but I've thought that, my kids might be the first generation that actually doesn't replace itself in this country, or replenish its own numbers. Who's going to provide the labor force? Who's going to provide the retirement?
Exactly the problem. And demographers are,
concerns.
Banging their heads about this, because if you think about how the population was shaped in the past, let's go back to 1960. If you look at the population pyramid, can you see my hands like this? It was like this, right?
There you go.
So the top was old people, very few, very, very old people, and lots of babies, right? And then what's happened is this has happened. So more and more people living longer, that's good, but somebody has to take care of them, and fewer babies. And in the middle are the people who's going to support the old people and the young people. That's shrinking too. So it's a real social problem. And for us, we depend on Social Security and Medicare and these government programs, as do countries all over the world. But for older people who can't, provide their own medical care, I don't know. I don't know how we're going to do this.
No, it's huge. It's a grave concern. I don't know either, and that's alarming to me. And I'm really quite shocked that more of the world doesn't have that same response. Which, by the way, I want to just read this from your prologue here. It says the 2017 publication of my meta-analysis on sperm count decline in Western countries put this issue on the radar screen, grabbing headlines and television coverage around the world. But the feelings haven't translated into committees being formed, environmental policies being changed, safer chemicals being manufactured, or other concerted efforts being made to address the suspected causes or protect our collective future. That's disappointing, and that's hard to understand, frankly.
Change is really difficult. Do you know that we're still battling the problem of asbestos? Outlawing asbestos.
It's been 100 years or something?
I mean, tobacco smoke is still with us, so we don't respond to public health threats very well. And people don't like to be told what to do. No. So it's a big battle. And then the companies that are making the chemicals that are playing a role, certainly not the whole story, but playing a role in these declines, are not eager to change production.
Right.
Even if we knew how, which, we don't always know. Right. So it's a real challenge. And that's why I'm talking to you and anybody who will listen to say, let's be aware. Let's be aware of this problem and think together how to solve it.
Right.
It's a big challenge.
Okay, so let's address the big elephant in the room. What's causing this? And that's, as you said, it's difficult to pinpoint, but we certainly have. You have an extensive body of research on a group of endocrine disruptors you've mentioned already, hormone disruptors, called phthalates, Phthalates, commonly found in fragrances, preservatives, as you mentioned, plastics, big source, which are everywhere. And because these things are everywhere, they're easy to test for, right? I mean, you can find them in the urine, you can measure them. Now, one good thing, perhaps, is that, as you mentioned in your book, this is a little good news. We like to sprinkle a little good news in here. These things are cleared actually quite quickly from the body, maybe as short as 48 hours.
4 hours is the half-life.
How long?
4 hours.
4 hours half-life. Wow.
Half-life. So that's half.
So we can get rid of these things, but the problem is that we just keep loading them in the other end, right?
Right.
So some behavioral or changes need to take place. So let's just. I love your admonition here. When we talk about what to do, you say, "Don't let perfect become the enemy of good." And I hear that all the time from people. Oh gosh, may as well just go give up. Look, there are things that can be done that can make a real difference, and so I'd like to leave people with what some of those are. And is it fair to say that maybe a couple of good strong divisions might be lifestyle, and then perhaps artificial or chemical exposures?
Yes.
Okay.
Well, the lifestyle end of things are not surprising because they're the same recommendations that your doctor will give you for your heart health.
Okay. Interesting.
Okay. Right. So things like
logical
smoking, cut out smoking, don't binge drink, get more exercise, don't be a couch potato. Stress is a big one, which is pretty hard these days to control. But these are all factors that measurably decrease sperm count and impair fertility.
Okay.
So that's the easy part of the story. Not as that they're easy to change, but they're easy to get people to agree on, I think.
Yeah. Well, let me just touch on one thing there that I loved how you talked about. Look, we're realists here. We know we can't eliminate stress from people's lives. And in fact, nor do we really want to. There is such a thing as good motivating and driving stress, right?
Right.
But we're not talking about that kind. We're talking about the sort that is destructive and
right. I mean, we asked men and women in our studies about their major life events. And we all know what major life events are: moving and divorce and change of job and blah blah.
Death of a parent.
And so, if men or women had more life events. They had poorer function reproductively. That's, lower sperm count, longer time to pregnancy, and so on. It's a no-brainer. But doing something about it, my gosh, you got to get married or divorce if you do need to, I don't know, but and you got to move when you get a new job. And so there's no avoiding them. Just to be aware that these things can affect all parts of our health, including our reproductive health.
Okay.
But so that's even not what I talk about very much. I kind of put that aside because, hard to control that. Diet, maybe, by the way, the kind of diet you eat matters as well for your sperm count, like a Mediterranean diet is helpful and so on.
Right.
But the chemical end of things is much more controversial and difficult.
Yeah.
And so you're right, Layne. I talk about phthalates a lot. That's what I've studied since I heard about the phthalate syndrome, affecting the development of male genitals.
And I think they're representative of other things too, so I like it.
That's right. But I should say, I'd like to mention some of the other kinds of chemicals that we worry about. And so phthalates make plastic soft. Soft water bottle, soft rubber ducky. Okay. Then there are chemicals that make plastic hard. So phthalates are anti-androgenic, and the bisphenols, like BPA, bisphenol A, they make plastic hard, and they are estrogenic. So they increase estrogen. So there's this flip side. You can increase or decrease androgen. You can increase or decrease estrogen, right? But much more commonly, these chemicals will lower androgen and increase estrogen. Mm-hmm. And as you know, these are related through a feedback, So.
Yeah.
And so then there's the I like to call them the barrier chemicals, the PFAS chemicals. Those are barriers to oil and water, like Teflon-coated pans, rain jackets that are water repellent, pizza boxes that are coated to keep the oil from going through. They're barriers. They're barrier chemicals. And they are much longer lived in the body and in the environment. They're called forever chemicals. They're not forever, but they're much, much longer than the phthalates and the bisphenols, right? And there are the flame retardants, and then there are the pesticides, right? And they're not always separate, like phthalates are in pesticides, because phthalates help things to absorb through your skin and help the plant absorb the pesticide into the growth. And so they're put in there, and they're put into personal care products because they increase absorption, and also retain scent and color. So anything that's fragrance will have phthalates in it, as well as parabens. So parabens is another class. So there's all these classes of chemicals that are produced in, we don't know how many, the numbers change a lot, but, I hear 80,000 chemicals in commerce, who knows, but a very, very large number. And a lot of them are fantastic. They enable us to live the lives we lead. And we're very dependent on them. And I'm not at all advocating that we do away with the use of manufactured products at all. Yeah. But I'm just saying we have to learn to make them in a safer way.
We do.
We have to learn to make them in a way that the components, the chemicals in the product, don't influence our body's hormones. Because here's one example, phthalates affecting reproductive tract. There's proof of principle that they can do this.
Yes. All right. So let's look at then the things that people can do then to minimize that chemical footprint or that chemical influence.
I mean, food is the number one target I would go after because it's a great source of many of these phthalates, bisphenols, PFAS, and so on. And I would, you could go through your kitchen and do an inventory and try not to use Teflon-coated pans. Try not to store in plastic. Definitely don't microwave in plastic, because when you heat these things, they are not chemically bound, these chemicals, and they leave the matrix and get into the food. So,
It's like called leaching, right?
Leaching, exactly. Avoid keeping your water bottle in the back of your car where it gets warm. In other words, you don't want to warm up things that are stored in plastic and then eat them or drink them, right? And then if you can't afford it, I would say you eat organic, because there's many hormone disruptors in pesticides. Not everyone can do that. Not everyone can find organic food, but that's one recommendation. And when you buy your personal care products, first of all, try to buy them without smell, because that indicates, that's like a marker for a phthalate and a paraben. And look at your old furniture, your old sofa, and so on, which probably has flame retardants, which also emit endocrine disrupting chemicals. So it's difficult. You can't do it all.
You can't.
I would start with your food and water. And by the way, we haven't talked about this, but the new buzz in our field is microplastics. I don't know if you've heard about microplastics.
Yes.
And these are in our air, and they're in our water, they're in our food, they're found in our bodies, and all, including in seminal fluid, by the way. That's been recently found.
Oh my
Microplastics in seminal fluid, measurable in seminal fluid.
So define for us what's a microplastic. How exactly how small are these things? And are they just little chunks of plastic?
I don't remember, Layne. I wrote it down and I don't, but it's small.
But if they're in body fluids, that's pretty small.
And there's nanoplastics, which are bigger, and then there's plastics, particles. So they're all, the question is, what do they pass through? So now we know that they can go through the testes barrier, so-called. Whether they go through the blood-brain barrier is not known. They go through the placenta because they've been found in the placenta. So this literature is very hot right now. There's thousands of articles that have come out in the last 2 years, and mostly on where these things are found.
That's great news, actually. I'm glad to hear that.
But so you can do something about your air. You can use a HEPA filter. Okay. Change your bag on your vacuum often. Leave your shoes at the door.
And you can get HEPA filter bags, by the way, for the vacuum.
HEPA filter bags. Try to keep your air as clean as possible, because we're not aware of it, but it's coming in all the time. Try to keep your water as clean as possible. Either I personally use a desk, or countertop distiller, which is not expensive and takes everything out. You can filter your water. I would be careful about water in bottles. They tend to be plastic, and you don't know where that water comes from. But and then worry about your food. Yeah.
Can we talk about that for a second? These plastics, we've gone over that extensively in my Instagram page there about these RICs, which by the way is resin identification code. A lot of people call them recycle codes, but really it's from the plastics industry that indicates what the thing is made of,
right? And
therefore how likely it is to leach out or be unsafe. I find it interesting that you've stated that the number ones, the PET, you're okay with those.
Yes.
Okay.
But it's relative. It's relative.
Right, of course.
So certainly, we'd
like to eliminate them all, but
yeah, right. But
not practical.
PET, the little phrase I've used for a long time. It probably isn't quite accurate anymore, but 4, 5, 1, and 2, all the rest are bad for you. Uh-huh. The problem is like a 6. So a 6 could be BPA. Uh-huh. But it could also be potatoes.
It's kind of an unknown category.
New and,
Yeah.
So that's the other category. So we have to be careful about that. And also, like you say, PET, there's been studies showing estrogenic activity of PET.
Yeah.
So it's definitely try not to use a water bottle with phthalates in them.
Well, and the name, let's face it, is right in the word phthalates, right in the name, polyethylene terephthalate.
Right.
It just raises suspicion. But
Yeah.
I understand what you're saying. There's such a thing as less worse.
Yeah.
Right. So then the 2, 4, and 5. Those are I think probably your better choices, as you mentioned. And then is it safe to say that a good activated carbon filter or charcoal will remove most of these estrogenic compounds? Maybe not.
I
heavy
personally
metals.
haven't studied that or looked at that in detail. I have to say I don't know specifically what is removed.
Okay, well,
I do know that distilling removes them all.
Yeah, distilling would, and then reverse osmosis is good as well. But
Right.
for people will immediately come up with these questions. So which filter? And the guidance I like to give is a good carbon filter takes out a massive amount of these, percentage of these, and it's a good starting point. Beyond that, people probably ought to get their water tested.
Yeah,
there are good companies out there
can't
that do
afford
that.
it. Yeah.
Yeah. So just one other thing that I wanted to talk about before we finish up here, and that is, we've talked about exposure to these androgen blockers, which and androgen means testosterone. So those that block that or inhibit that, when they're introduced in utero, can cause some changes that are irreversible. That man now is just going to need to live with throughout his life, as opposed to those that have exposures to these things as an adult. Simply removing them makes the process reversible and the symptoms to go away. You can have significant improvement there, right?
Yes, and I'm so glad you brought that up. Timing is really, really critical. Mm-hmm. Not only at what point in pregnancy, but at what point in your life. And and a great example is that a man's smoking will have less effect on his semen quality than his mother smoking or his father's. And the damage done by his mother's and father's smoking is, as you say, irreversible. Whereas if he stops smoking, he can regain his sperm count.
His function, yeah. So and then it just gets freakier than that. I mean, it gets almost Frankensteinian. Is that a word?
Right.
We can actually change the structure of our DNA and make these things, as the word you like to use, and I love it, is intergenerational. You can pass this on. You can actually change the structure of your DNA, and so it gets passed on to your offspring and theirs for several generations.
Right.
What can you give us an example of what?
The simplest way to understand that, I would say, and the path that's clearest and most widely accepted, is that you have, say, a grandmother who's exposed, let's say, phthalates. And then that's a pregnant woman, and she is carrying a male, and that male's germ cells are affected, as we know, by his sperm count is lower. Mm-hmm. But within his body are the germ cells for his son, and those are also affected. Right? So some people say this goes for 7 generations. I don't know that. It's possible. And it's not absolutely clear. The path I described to you isn't a genetic change. It isn't changing the germline, right? It's just impacting the development at various stages. But the changes in the germline, the epigenetics, if you will, is the very hot topic now and under a great deal of research, and where it's going and how far things are being disrupted. How many generations is still up for grabs, but it's definitely a risk for later generations. You can say that.
Well, and it's pretty alarming too that then they can add their damage on top of that and just make it compounded, right?
Yes, that's right.
Goodness, there's no wonder that trend is
it's
where you found it.
multi-hit. It's a multi-hit model, right?
Yeah.
Each generations is hit over and over again. You don't start it with a clean slate A new baby's born is not starting with a clean slate.
Boy. But I just, one of the most impactful things that I learned in your book, I think, is how important it is that a mother fiercely protect her developing fetus at those critical times. And we know that's pretty much in the first trimester, right?
Right.
We're forming
Layne,
organs.
You wisely talked about how it takes 70 approximately days to make a sperm. So that means that the man, prior to conceiving that pregnancy, the sperm that are going to conceive the pregnancy have been developing for 70 days. And in that time, that's a vulnerable time for those sperm. Because damage to those sperm, for example, the man smoking at that time, will affect his son's semen quality when he grows up. So it's not only the mother who has to be careful, it's the man who has to be careful.
Right. Yes, point well made there. It's just, I don't know, it's really kind of scary. Men have to really kind of take some ownership here and realize that, okay, that fact alone, that what you have done, you got to remember what you've done. If you're trying to have a family and a baby, you need to remember what you've done 2 months ago, because that, as you said, that's the sperm that's going to conceive that child, not what you've done that night,
right?
Necessarily. So it definitely makes you look at that stretch of time and realize that, gosh, this is a commitment over time. I've got to make my contribution healthy as I can,
right,
and not be a cause or part of the problem.
Right. And this is we're mostly talking about reproduction, but I just want to mention that testosterone is also needed for other systems in the body.
Oh, for sure,
including the brain. And there are many studies, including some of ours, which show that when the mother is exposed to higher levels of these chemicals, there's more problems, maybe less babies born, less neurotypical influences on language development and so on. So, so just as we talked about the differentiation of the genital tract, there's a differentiation of the brain.
For sure.
And that also depends on testosterone. So it's not just about reproduction.
Yes. Thank you very much for bringing that up, because that's also a part of what I do, is help these guys understand there's a whole other group of things to consider beyond the sexual aspects of testosterone. Right. And, the other thing too that I really appreciate that you dealt with in this book, I thought it was very brave, is these things back in utero, having those effects on the brain, I'm quite sure has an effect on gender dysphoria and issues around that. And it's something that's very difficult to talk about. In fact, I'm really not going to talk about it very much more than that, because people there are some people out there that believe they're the only ones that should be able to talk about it, and they're intolerant of even discussing it. Right. But the fact that science is now kind of creeping into that and lending some understanding, I think is very important, and I appreciate the space you gave to it.
I just do want to add, though, that it is not my opinion that these chemicals have or don't have a role in gender dysphoria. I have not reached an opinion on that. I don't know.
Okay.
We do know that they can influence homosexuality, because we can produce homosexual animals in the presence of, say, a pesticide. That's been done in the laboratory. So those are two different things, and it's not to say that certainly that one is bad, or it's just a difference. Difference that can be caused by.
And please, folks, don't understand. We're simply talking about what the science shows on this, and if we're scientists and we're clinicians and we're practitioners, we have to be able to talk about this. Please don't respond defensively or in an offensive way. None is intended.
Right.
I guess I was referring to there are there are some studies that show that it influences the mode of play or preferences with play.
Yes.
In a developing toddler.
Yes.
The association is very loose. I admit, but it certainly makes. There's some logic there, isn't there? That there may be some things going on if we're talking about.
And I know that sex typical play is very controversial because I've done those studies. The studies you're referring to partly were mine, but they're controversial because people say maybe girls play with dolls because they're given dolls because that's what's socially acceptable, and boys play with guns for the similar reasons. I just will add that monkeys, the vervet monkey, 2 studies on the vervet monkey showing that monkeys make similar toy choices to humans.
And that's what I found really interesting, because then the boys would tend to go for what, like a vehicle or something on wheels?
The male monkeys chose the rolling car over the doll, and the females tended to choose the doll. So there
what does it mean? I don't know.
Something biological in there,
Yeah, there obviously there's some biological force. That's the only thing we have, right? Is biology. Right. What else could be affecting it? How it does, though, I is certainly yet remains to be discovered and found out. But I very enthusiastically recommend that you read this book. This Countdown is the name of the book. Just a very thorough, nothing spared look at these issues, and some of them that are difficult to talk about. I commend you for that, and there's so much more depth in this than we could begin to touch in a short podcast like this. But boy, I heartily recommend it. The depth there is just fantastic. Thank you so much
Thank you for having me, Layne.
Well, listen, first of all, for your work, your life's work. My goodness, it's been a massive contribution to society and to all of us that care about these things, which should be everybody, but sadly isn't as many as it should be. But thank you, and for writing this book and getting it out there in a way that really penetrated and got to a lot of people. I hope that we can help to continue that. That would be my best wishes. Thank you, and again, appreciate your time today.